I'm Dalen Einhorn, president of the Junior Naturalist Earthkeepers Club. It's a club dedicated to teaching kids about the environment and how we can protect it. And today we're doing a shark dissection where we're looking into sharks.
Has the capability of living in fresh waters for a very prolonged amount of time, and that is a bull shark. Yes, bull sharks have been known worldwide to go up into freshwater areas. They've been found up in the Mississippi River. They've been found in lakes and rivers up in the Carolinas, all the way up to Virginia, even as far north as Rhode Island. During the summertime in Australia, when it gets very, very rainy and they have their monsoon season, they actually have been known to swim about 50 miles inland, which is absolutely crazy. They have an extra protein in their blood that allows these guys to actually hang out in fresh water for a little bit, so their body is able to actually handle it, which is quite nice. Okay, so with that in mind, all right, let's look at a little bit of our differences between our bony fish and our sharks. I'm kind of prepping you guys for our dissection because we're going to talk a little bit more about the external anatomy. If I'm talking about external anatomy, does that mean inside or outside? Outside. Excellent. Yes, that means the outside of their body. So, one of the main differences, like we said, is that sharks have cartilage and fish have that of bones in their body. How do fish and sharks breathe?
Gills.
They breathe by gills. Excellent. All right. So the water, right, has dissolved oxygen, which they breathe. That is dissolved in the water and it flows over. They have gills, right? Now, with our bony fish, if you guys notice, even up to the pinfish up in our exhibit room up there in the tank, you'll notice that some of them just kind of hover around, just kind of hang out a little bit, right? Well, they also have a tiny little fleshy covering over their gills. It's called an operculum. This operculum acts like a vacuum. It allows these guys to hang out and suck water over their gills because their gills can grab all those tiny little pieces of dissolved oxygen and they can breathe and then it flows right out. So those guys actually don't have to swim to get oxygen pumped over their gills. With sharks, however, you guys will see, they don't have that operculum. They just have their gill slits, all right? Now, most commonly, sharks will have 5 gills. There you go. Oh. But he also drew the gills, all right? Now, remember, they don't have that covering. It's called the operculum. Now, majority of our sharks, like I said, have 5 gills. But there are some sharks that are known as 6-gilled and 7-gilled sharks, okay? The scientists didn't come up with any fancy name for them. They literally just call them 6-gilled and 7-gilled sharks. We don't know a ton about the 6-gilled and 7-gilled sharks. Reason why is that they live very, very deep, usually off the coast of volcanic islands like that of Hawaii and Japan, where there are much more nutrients and a lot more food for these guys to eat. What's really cool though is that they live at such deep depths that oxygen there's not a lot of it down there. So they actually have tiny little frills and their gills actually come outside of their gill slits a little bit so they can get as much oxygen that they can when they're down in that area. Now, there are some sharks just like this guy we're going to cut open today. The guy that we're going to look at is known as a spiny dogfish shark. But also any bottom-dwelling sharks, sharks that live at the bottom of the ocean floor, okay? These guys, all right, if they had to continuously swim, what do you think would happen to the bottom of the ocean floor? If they had to continuously swim and you're a shark hanging out at the bottom, all right, if you were looking for food and trying to be stealthy and trying to ambush your prey, if you had to continuously swim, what would happen to the bottom? Yeah.
The sand would move up.
Yeah, exactly. The sand would move up, all the sediment would get disturbed, and your animals that you're trying to eat, your tiny little crabs, your little shrimp, your other little sea snails, they're going to get right out of there because they want nothing to do with you. So these guys actually have a little bit of an operculum. It's called a spiracle, and it usually sits right in front of their gills. Okay, so these guys pretty much just hang out at the bottom of the ocean floor, and they can pump little pieces of oxygen. You'll see their gill slits moving in and out, and they actually will use it to kind of hang out and get there. Okay, so that's another thing. Now, we as humans have skin, right, to protect ourselves. What do fish have? What's their equivalent? What's their, yes, honey?
Scales.
Excellent, they have scales. Now, there are tons of different types of scales all over, but we're going to focus on the shark scale. The shark scale is really cool. It's called the placoid scale. And if you guys have ever heard of placoid, it sounds really familiar to the word plaque. Here's a plaque before. How many guys have been to a dentist before? Yes, what does a dentist scrape off your teeth if you don't brush them a lot? Plaque. Yes. If you break down the word placoid, means plaque, means these like little pits on your teeth. But sometimes scientists call the scales of our sharks dermal denticles. You break that word down, dermal means skin, denticle, like a dentist, means teeth. So if we were to look at a shark's skin underneath the microscope, you would see that they actually look like tiny little teeth, just like that, like Nate drew. Now, these teeth all point in the same direction, and in between those tiny little teeth are actual tiny little gel-filled pores. Believe it or not, that is their taste buds. So if I was a shark and I brushed up against you like this, technically, I would have been tasting you. They can taste with their skin. And just like how we lose teeth, all right, these guys will replace their teeth or their scales throughout their entire lifetime. Another really cool thing that these dermal denticles do is that these guys, since they all fit and all go in the same direction, it helps these guys remain, to say, very easy for these guys to move and swim without having water constantly moving. So they create a little bubble around their body and they're able to kind of swim in the water without any problems. Okay? So those are the dermal denticles, which are pretty awesome. They eat meat with their teeth. Excellent, all right? So we, as humans, we have two sets of teeth. We got our baby teeth, and then we have our adult teeth. Right? Most fish, okay, will actually have that same concept, baby teeth and adult teeth. Now, since these guys have to continuously swim, they're burning up a ton of energy within their body. What do we as humans do to replenish our energy, to make us feel better? What do? We do two things. Name me one. We sleep, that's one of them. What's the other one? We eat, excellent. So we eat and we sleep. Here's the cool thing. We, as humans, are the only true animals that need a uninterrupted 7 to 9 hours of sleep. Okay? Fish do sleep, but they do it a little differently. Okay? They can shut down their brain, one side of the brain, and then the other side of the brain. Okay? They don't actually go into a deep sleep, but they just kind of hang out. They don't really do anything. When that one side of the brain gets tired, they then switch it over. So they actually don't sleep, and they really just need like anywhere from 30 minutes to a couple of hours, unlike us, right, for them to be active. So if you're continuously swimming, you're gonna get hungry. You're gonna burn through a lot of energy, okay? These guys have to continuously eat to keep up that energy. On average, a great white shark can eat up to 150 pounds of food per day. Can you guys imagine eating 150 pounds of food per day?
Yeah, that would be a lot.
You would be a lot, and I don't think you guys would be able to move at all, right? Because if these guys stop swimming, what happens to them? They die because they stop breathing. Excellent. Yeah, so for that reason too, sharks really can't. They can't swim backwards at all. All right? So if you're also eating a ton of food, all right, what do you think is going to happen to your teeth over time? They're going to dry out, they're going to fall down. They're basically going to start out razor sharp. And remember, each species of shark, depending on how they eat and what they eat, is going to have a different tooth depending on their function, if it's for stabbing, if it's for ripping apart, or if it's for gnashing. Okay? These guys, all right, what they do is that, like I said, it depends on what species are, but anywhere from 1 to 2 weeks, they go through cycles of teeth. Right? These guys, their teeth will start out very, very sharp. Eventually, they're going to wear down. They don't become very effective. They can't really eat anymore. What they do is that these guys will actually have extra rows of teeth in their mouth, anywhere from 3 to 5 of them. Yep. So as soon as that tooth wears down, it's going to come up, it's going to fall out, and a new one's going to replace it. Generalizing, on average, a shark can go through about 40,000 teeth in their entire lifetime, which is a lot of teeth. So that's another thing, too, with these guys. Now, when these guys swim, how do they mostly swim? With their fins, all right? And there's actually several types of fins that we're going to talk about, and we're going to point them out to you when we actually do our dissection. So the first fin that we're going to draw is the one that everybody thinks about when you think of sharks, is that top fin right there. That top fin is called as the dorsal fin. Excellent. This guy doesn't really do a lot of the movement for swimming, but what it does instead is it actually helps with keeping these guys straight and upright so they can remain as hydrodynamic and very efficient, meaning that they're able to get a lot of food and they're able to move through the water really, really easily. So this is that dorsal fin, helps them keep them upright. If they didn't have that dorsal fin, they would kind of be swimming in circles. All right. The major area where they do a lot of their swimming is going to be that tail fin. That's called the caudal fin. Okay? That is their big fin. And depending on where the shark lives, you're also going to see different sizes of that shark fin. Now, our spiny dogfish is a bottom dweller, so he's going to have a very big top lobe up here and a little bottom lobe. If he had a big bottom lobe, he would constantly be stirring up sediment and he wouldn't be able to catch any food. So any bottom dwelling shark or shark that lives at the bottom is going to have a big top part of his caudal fin and a smaller part of the lower fin. Now, if you have a big fish that swims all the time, like a great white, or a mako, or even a whale shark, that top portion and bottom portion are going to be equal to each other. This gives them a lot of movement so they can actually move very, very quickly over great distances for a long period of time.
So it's going to be symmetrical.
Correct, absolutely. It's absolutely, they're equal in size and they also are symmetrical. Great job. Now, the other one that they have are these guys right here. Okay, these are known as pectoral fins. Now, when you see a pectoral fin on a fish, does it move?
No. Yes.
Yeah, it moves. You'll see them. They kind of hang out like this. Right? Sharks, on the other hand, do not. Theirs are fused together like airplane wings. Now, they can move up and down just a little to create lift, but these guys, their pectoral fins right here, actually help these guys, okay, lift to go in the water, excellent, and help with steering. Now, there is another tiny little fin right here. It's called the anal fin. Now, some sharks have them, and some sharks don't. They act like a rudder on the boat. But yes, they actually help these guys move around in that area. Now, there is another set of fin. Okay? So many fins, because some sharks have 2 dorsal fins. What? Some have 2 anal fins. Some have, the next group that we have is new, they're called pelvic fins, and they're found right here. The pelvic fins, and we're going to see this when we go dissect our sharks, is going to tell you whether you have a male or a female. And we'll talk more about that when we do our dissection, because each shark is going to be different. Okay? So, another thing that we're going to talk about are their eyes. Okay? Yes, they have eyes. When do you guys think sharks do most of their hunting? Yes.
At night.
At nighttime, yeah. They actually do it in what we call the crepuscular hour, which is the area between dawn and dusk, okay? Just like how traffic is really bad here in Miami from about 5 a.m. to 10. Same for those guys too at nighttime as well, all right? These guys, they have to eat a ton of food. If they came out at that area, you have the crepuscular hour, okay? You have your day fish getting up in the morning. You have your night fish going to sleep or hanging out. It creates a huge traffic jam, but for those guys, it offers them a ton of food, okay? Now, because these guys are usually hanging out in a nocturnal environment, what are the size of their eyes gonna be compared to the size of their head? Are they gonna be small or are they gonna be big?
They're going to be smaller.
Think. Reverse that. If you're an nocturnal animal, they're gonna be bigger. Because do they have direct access to sunlight? No. What do they use instead, for the most part? Nope. If you don't get, what causes brightness in the sky at nighttime? The sun at nighttime? The moon, yes. The sun will technically, the sun reflects off the moon and things like that. But remember, it's not as bright as the actual sunlight. So most nocturnal creatures are going to have really big eyes because it allows more light to actually come in so they can see better. Now, another really cool thing about these guys is that they have a tiny little crystal layer in the back of their eyes. How many of you guys have dogs and cats at home? What happens when you shine a light in their eye at nighttime? Their pupil gets smaller. What else? What do you notice about the coloration of it? It gets black. Have you ever seen like a glowing eye ever come out of your dog or cat before? That's a big thing. Yeah. So before dogs and cats were domesticated to become pets, they were nocturnal. What they actually did is that these guys have a tiny little crystal layer. Okay, it's called the tapetum lucidum or tapetum lucidum, kind of like potato. You can say it anyway. All right. What it is that layer of crystal helps when light gets reflected into their eye. It bounces all over the place, basically illuminating their whole entire eye, allowing them to see better, and then that light bounces out. We as humans, right, are mostly diurnal, meaning we hang out during the daytime, so we do not have a tapetum lucidum or tapetum lucidum. Another cool thing about these guys is that they actually have 3 sets of eyelids. Right? We as humans, we have 2. We have an upper and our lower. All right. With sharks, believe it or not, and we'll talk more about this in a bit, their sense of sight is one of their strongest and is actually one of their best, so they actually need it. What these guys do is that if they're trying to get food, they're in constant danger of getting attacked by a rogue fin, smashing them in their face, possibly poking them in their eye. So these guys actually do something really cool. They actually will close their eyes. It's called the nictitating membrane. There's a membrane that goes from, your eyelid goes from top to bottom, then the little one goes from bottom to top. Then there's a third one. It goes from here across the eye. These guys will actually roll their eyes in the back of their head, close their eyes, and then they will actually use a really cool sense, which they have right underneath their chin, which we're going to get to next, and to kind of hone in, kind of like a metal detector, to get what they want. These guys also too, let's talk a little bit about their senses, because like I said, they use that bottom sense right here, that random little sense they have, to actually hone in and find their food. So, we as humans, how many main senses do we have as humans? We have 5, okay? Can someone name them for me? Name me one. Vision, sight. Go. Smell.
Touch.
Touch. Taste.
Here.
Hearing. Okay? Am I missing one more? No, I think we're good. All right, so we have 5. Fish and sharks actually have 6. They share another one. It's called the lateral line. What? And it's actually a line that runs right across the middle of our shark. Now, when you guys see our shark, you're going to notice how the top is much darker than the bottom. Not only does this line provide an extra sense, it actually kind of makes our shark, puts our shark in half. It's called counter shading. And it's actually really important camouflage purpose that sharks and other fish have. Reason why is that if I'm a predator and I'm swimming over my shark, as I look down into the water, does it get lighter or darker in coloration? It's gonna get darker, all right? If I'm an animal and I'm swimming above a shark, my shark has a dark top, they're gonna blend in perfectly with the bottom surroundings, and I might just swim right over him and not even notice him. Same thing, if there's a shark above me, okay, and I'm swimming underneath him, it obviously gets lighter as I look up towards the surface because of the sun. That allows their bottom to actually blend in with their surroundings. So actually, it's pretty neat because it's an extra camouflage protection. But that lateral line, which is that little sense that they have, is that line, it's tiny little pores that are filled with very stiff whisker-like hairs. Whether we have big storms, because if we have a big storm coming, they usually go further offshore. Now, sharks take it one step further. Instead of having 6 senses, they have 7 senses. They actually have one, and that's this one right here that they use for feeding. It's called the ampullae of Lorenzini, B-A-O-L. Okay, and it's obviously named after a biologist. Obviously. An Italian biologist who actually found out that when you look at a shark, and we'll be able to see it, when you squeeze their chin, little jelly-like comes out of these pores, okay? Now, we as humans all have, believe it or not, a magnetic field around our body. Can you say your magnetic field? Can you honestly see it right now? I don't see one. Does anybody else see a magnetic field around them? No. We, as humans, have tiny electrical currents running through our body. How do you think our heart pumps? Tiny little electrical currents. But yes, we have tiny electrical pulses within our bodies making our heart pump. Okay, we can't see them, but doctors can with EKGs. All right, it's basically detecting a tiny little magnetic field around our body. Sharks have a built-in EKG system within their body. So what they can do is they can detect heartbeats and magnetic fields of the animals and objects around them. Now, if you're an animal and you're nice and healthy, your magnetic field is going to be pretty strong and it's going to vibrate equal. If you're sick or injured, what happens is your magnetic field is often broken and it's going to go in and out really, really crazy. So they can use that to detect whether it's something that is really easy to get, like an injured fish, or, if there's a big shoal of fish that they obviously will have to kind of herd in together. The AOL, like I said, they use it, basically they roll their eyes, put down their wonderful little eyelids, and then they use that AOL to hone in on what they want. Now, they can't use their AOL when they're very far away, only maybe a foot in. Now, everyone thinks that scent, their sense of smell, is their strongest one. It's actually not, right? Yes, they have a very great sense of smell. They can detect from water currents particles of blood, okay, what we call parts per million. If you took an Olympic-sized swimming pool and put a shark at one end and then a drop of blood in the other, they're able to actually go ahead and detect that blood. But here's the thing, you can detect whether it is something you want to eat, like a big fat seal or sea turtle, or something you don't want to eat, like that of a human. All right? So, yes, they actually have a very good sense of smell. Their number one sense though, is actually hearing. And yes, they do have ears. They have what's called a tympanic membrane, just like frogs do. It's basically a little hole right behind their head. They don't have external ears like we do, all right? They actually have it right behind the eyes, and it's just a little membrane that they put over, okay? So they're actually able to hear better. Reason why is that as I'm talking to you, sound is bouncing off of you guys, the stairs, the steps, the trees, Nate, the board, Caitlin, the sharks, right? It's bouncing all over the place. However, in the marine environment, there are no barriers like that. So sound actually travels 5 times faster in water than it does on land. They can actually hear things up to about 1 mile to 2 miles away before they actually see them, which is actually really cool. Hence why you can hear boat motors coming, say you're snorkeling or diving, you can hear them before you actually see them, which is actually really cool. So what we are going to do now is we're actually going to get ready to do our actual dissection. We are going to split you guys up kind of into small little groups of 8 or so.
Cool shark, excited?
Yeah, very.
If you rub it the other way, you're gonna feel it's very, very rough. So I actually want to do that with you guys first before we put our gloves on so you can actually get a feel for it. So rub your hand one way, other way. See how it's soft and one's hard? Yep, good. It's not you, it's awesome.
But it smells bad.
It does smell bad because we have to keep them in a preserve so it doesn't, we can actually dissect them. You guys can touch that shark. Go, touch your shark.
I want it.
You touch it?
Don't want it.
Johnny?
Yeah. I'm gonna smell like fish for a long time.
Some seals, some dolphins do. So that would and killer whales as well. That's technically a dolphin. So they have this lighter color on the belly and a darker color on their back. That's like a 3-dimensional type camouflage.
And that is not a good material for you guys to be licking off of your fingers. So, gloves for everybody. Toss them on. And when you're wearing gloves, good protocol, don't touch your face. Hard. Right in front of the dorsal fins, you're gonna see this hard little piece there. It used to be a big spine, a big venomous spine. What happens when you stab yourself with a venomous spine? Well, you don't die, but it does hurt. It doesn't feel good. It's like getting stung by a bee on steroids. So, what they did before we got these for dissection, they clipped the venomous spine off. I'm not 100% confident that you couldn't find a way to stab yourself on it still, so do look at it, squeeze it from the sides, but don't push your finger hard on it, all right? But check it out, guys. Get your hands in there. Keep your mouth off of the shark, but check out all those fins. I'm gonna get that board turned around.
The tail's been cut. Oh, what's in his mouth?
That's what we're gonna talk about. That's where his teeth are. His teeth are really, like that jaw, that muscle that they have is really, really strong.
Oh, it's all slimy.
All right, guys, show me where the caudal fin is. The caudal fin. If you don't know what it is, you can either look at the board or you also have an ID guide in front of you for the external anatomy.
It's this
the stuff
big.
on the outside.
It's
Right, it's the tail fin, right? And just like Julie was saying, sharks, a major difference between the sharks, like the chondrichthyes, the cartilaginous fish like rays, skates, sharks, and bony fish like any of the other fish you usually see out on the reef, is their tail. Sharks, sometimes they'll be closer than these guys. These guys live on the bottom, so their upper lobe is way bigger, but sharks will always have a larger upper lobe than a smaller lobe. It's called heterocercal. It just means that they're not the same size.
Find me the gills. Okay, the gills are gonna be located on the side. What I want you guys to do is go ahead and count. Count how many gills they have on each side.
There's 4.
How many did you
5.
guys get? 5. You guys see 5 on each side? Remember how I said these guys are bottom dwellers and they have an extra little pore in front of their gills called the spiracle? Point that one out to me. That's their spiracle, right? Remember, it's like kind of like a mini vacuum that sucks over every time.
It's like that. Looks like the shark is old.
Joel, don't touch your shark.
Actually, we'll need them so they can sit at the bottom and not disturb them. You see them? That dorsal fin, that top fin. Find me that top fin. It's called the dorsal fin. Yep. You guys can go ahead and lift it up. Okay. Find me the pectoral fin. Find your shark.
Pelvic. Oh, it's right there.
Right there. Nope.
Oh, yeah.
Nope, stop. Pectorals, pelvic right there.
I think this is
What would be the only part of a shark remain you would see after a while? Like after 100 years? What's the one bone in his body? Teeth, right? Like if you go to a museum, you're not seeing a shark skeleton because it's cartilage. You're seeing the teeth. That's what you're seeing. That jaw is what you're seeing because it's solid. Teeth have a lot of calcium.
Let me push the eye. No. How does that feel? I just touched it. I'm gonna touch it. I'm gonna squeeze its chin. Where's the chin? Right here. I want to squeeze its.
Another thing I want you guys to check, we should name our shark. Male or female, does anyone know?
Male.
How do you know?
You have to check the pelvic area.
So these are pectoral fins, right? But we want to check the pelvic fins back here. There's a way to tell. On the females, you'll have your pelvic fins right here, and there'll be nothing here. On the males, you'll have these big things called claspers. Claspers are used for reproduction. When they want to mate with a female, they're going to need these, all right? So if it's got these big duders here called claspers, you're going to have a male, and if it doesn't have any of those, you just have a female. This area is called the cloaca, and that's where they're going to either poop out of it or put babies out of it. Either one of them. So all the sharks will have this little hole here, but the females won't have any of these structures here. We don't need that. So it's a boy, so we should name him. Come up with something good. Let me get you another through all the veins and the arteries, so you can tell when we open it up, it'll be red and yellow, I think. So where do you look to find if it's a male or female? Right, so you look back here, what are these fins called? So these are the pelvic fins. So when you look at them, what structure are you looking for to tell the difference, do you know? The penis.
Yep, you can see how the holes open on the side. So when water flows in, it's flowing across those feathers, those gills, and all of that surface area, all those little individual pieces and strings, that's what's pulling the oxygen out of the water. So that's our first stop on this shark journey. Next up, any other part of the main cavity.
Next we need to find the organs.
Yeah, next we need to find some sweet organs.
It's hard.
It is pretty hard, and it's a combination of the dermal denticles. They have thick muscles and skin around there, but also because of that preservative, it's kind of made their body parts a little bit more rigid than normal. Nothing across the side.
It's hard. Is it hard? It's
Are you going to get a boy or girl shark?
boy.
Boy, cool.
Now where do we cut it through?
Let's have a boy or girl shark here.
A girl.
Keep it lifted up a little bit, guys, just so you don't go too deep with it, all right?
You might find some babies in there, some babies.
Yeah, because it's really big.
That would be cool. All the others are males, I think.
Just like the skin.
Liver looks.
I've never looked inside a shark spot. It's my first time seeing that one.
First time seeing it.
It's my first time. I look very excited. Look at this. Oh my god. See that? Let's go. Yeah, mommy, where's dad? Yeah. I think I see one of the organs. Oh, look, it has like a little. Why is that? Why? There's like a little line in between. But it's already dead.
It is already dead, but if we squeeze it, we can root internal organs that we want to show you guys, okay?
Here?
Yeah. I guess just cut.
In progress!
Are we gonna pull out the part with our tweezers?
We're gonna pull out everything.
Oh,
Yeah, let's stuff the oil. Who remembers where the oil's coming from? What organ?
Liver.
The liver. Very good. Now, what?
Is this the liver?
It is. I was going to ask you guys to try and find it. Looks like we accidentally cut a little bit of our liver, but that's cool. Let's see how big this guy is.
Oh my god.
His liver.
That's the liver, right?
Yeah, this is our liver. So look at your diagram. How many pieces of a liver are there for our shark? Three, because there's a median, a left, and a right lobe. This is a huge part of why a shark is an apex predator. Anyone know what that word means, apex?
Yeah.
What does it mean?
Like eternal?
Awesome. Literally means like best of the best, top, right? Apex, like if you're an apex predator, top of the food chain for your area. So being an apex predator, being an awesome animal that's very well evolved to survive in the ocean, this liver is a huge part of that. All of these fatty oils really help it to be buoyant.
That stinks.
It doesn't smell good. That is true.
That's what I meant by stink.
All right.
Ew, there's juice. What? Oh god. Oh, open it with us. We're not the only scared kids here. I'm not scared. I'm not scared.
But you guys guys can see that big blue, that's that big vein that connects their heart to all their surrounding blood things. So you can pass that guy around. I will be right back, okay? But be very careful. She's gonna get to the stomach, okay? Don't break it, don't break it.
Hold it real still on the palm of your hand.
Okay, Josiah, hold it out like this.
It's real. That's cool. Okay, you guys want to tell me what you're holding?
A shark heart. Nice.
I wonder why it's blue. Did she tell you what was in
I wonder if it's like the same.
Here's a fun fact.
How big do you think?
Turtles. It's a shark heart.
If kids want to join, they could like us on Facebook and they could sign up for the newsletter, and then they'll be able to get all the information about the events and they could come and register. Well, we have a seagrass adventure coming up, which is where we go into the water with nets and we look into the sand and we pick out animals that we see, and then we sit on the shore and we pass them around and we learn about them, and then we release them back into the ocean. I would like everyone to come.